A new NASA climate simulation suggests that extremely large volcanic eruptions, called flood-basalt eruptions, can significantly warm Earth's climate and devastate the ozone layer that shields life from the sun's ultraviolet radiation. Unlike brief, explosive volcanic eruptions that occur over hours or days, flood basalts are regions with a series of eruptions, perhaps centuries each, and occurring over periods of hundreds to thousands of years, sometimes even longer. Some happen at about the same time as mass extinction events, and many are associated with extremely warm periods in Earth's history. Researchers used the Goddard Earth Observing System chemistry climate model to simulate one such flood basalt eruption, the 4-year-long phase of the Columbia River basalt that occurred between 15 to 17 million years ago in the Pacific Northwest. The model calculated the effects of the eruption on the troposphere, the lowest layer of the atmosphere, with most of the water vapor and weather, and the stratosphere that is mostly dry and calm. Scientists expected to see intense cooling in simulations. However, they found that a brief cooling period of about 2 years was overwhelmed by an intense warming effect. In the simulation, the Amazon and East Central Australia reached monthly mean temperatures of 49 degrees Celsius. In the Arabian Peninsula, July mean temperatures were equal to or exceeded 55 degrees Celsius. In the central United States, there were extreme monthly mean temperatures equal to or exceeding 40 degrees Celsius. The simulations predicted a reduction in the ozone by about 2/3 over global average values, which is roughly equivalent to the whole planet having an ozone thinning comparable to a severe Antarctic ozone hole. Eruptions emit sulfur dioxide gas into the atmosphere, which converts to solid sulfate aerosols. These aerosols reflect visible sunlight, which causes the initial cooling effect, but also absorb infrared radiation, which warms the upper atmosphere. In the simulation, most portions of the atmosphere were almost completely opaque to the sun. Warming this region of the atmosphere allows water vapor, that's usually near the surface, to get mixed into the dry stratosphere. Water vapor is a greenhouse gas that emits infrared radiation to warm the planet. In the simulation, there was a 10,000% increase in stratospheric water vapor. These flood basalt eruptions also appear to have been common on other terrestrial worlds in our solar system, such as Mars and Venus. Although Mars and Venus may have had oceans of water in the distant past, both are currently very dry. Scientists are investigating how these worlds lost most of their water to become inhospitable for life. And if the predictions of this simulation are correct, extensive flood basalt eruptions could have contributed to their arid fates.